see design of reinforced concrete structures. We simply call it as DRC. What is the difference between normal concrete and RCC? So today lecture mainly aims to distinguish between the normal concrete and RCC. Why we call it as RCC? What is the difference between normal concrete and RCC? What we are going to do or what we are going to incorporate in RCC? As we all know that since we have studied in our junior classes like mechanics of solids and strength of materials, we have seen many types of beams and columns. For example, what are the types of beams? Simply supported beams and fixed beam and cantilever beam and continuous beam. So first of all, what is reinforcing? Why we have to reinforce the concrete? What does it mean, reinforcing? So reinforcing is something, a process by which we can improve the strength of a material. So this process is called reinforcing. Here we are going to increase the or strengthen the concrete structures or concrete elements by introducing reinforcement. That means we are going to introduce normal concrete bars, steel bars. Steel bars, that's why it's called as reinforced cement concrete. Also we call it as rebars. So this is the ultimate aim of design of reinforced concrete structures. What we are going to do is we are going to introduce reinforcement. That means reinforcing steel bars into concrete. So this is our ultimate aim. So I am telling now why we should introduce reinforcing bars in concrete. Why I should introduce rebars, that means reinforcement bars. We call it as rebars in concrete. Here is the reason why I am going to introduce steel into concrete, because the concrete is more stronger in compression. More stronger in compression. That means if I am having a tube size of 150 mm breadth, 150 mm width and 150 mm length. Okay. If I am having this concrete tube, if I push it like this, it will introduce a compression force into concrete, and concrete is more stronger in, way stronger in compression, and if I pull it like this concrete, it just will brittle. That means this is why I am going to introduce steel into concrete, because concrete is more stronger in compression. When I apply compressive force into concrete, it will be more strengthening compression. If I apply a tensile force, just like pull it away, it will break easily. Okay. Now this is the reason I am going to introduce steel into concrete. How it works? We are going to see how it works. Just like that. Just put your hands like this. This is considered like a beam. If you bend it like this, you can feel that your bottom of the hand stretches out and your top of the hand will shrink. That means when I bend a beam, so consider this is a beam. When I bend a beam, the compression force will be introduced on the top of the beam and tensile force will be introduced at the bottom of the beam. As I said earlier, the concrete is very stronger in compression and very weaker in tension. So the bottom of the section will be carried out by the tension force and top of the portion will be carried out by the compression force. So the concrete is less stronger in tension, the bottom will brittle and break down. So to reduce that, to keep a point of safety view, we have to carry out the tensile force introduced at the bottom of the concrete section. So that is the main reason we introduce or we incorporate steel into the concrete. So when a beam loaded or any horizontal member in concrete structures loaded, the top portion will be carried by the compression force, the bottom of portion will be carried by the tensile force. So as I said earlier, the concrete is strong in compression, weak in tension. The tensile force would be eradicated fully from the concrete. How do we eradicate the tensile force? By means of introducing steel. That is why it is called as reinforced cement concrete. First one is cement. And second one is aggregates. Third one is water. Here, the cement is we call it as binding material. The second one is aggregates. We can split up into two parts. One is fine aggregates. Another one is coarse aggregates. Coarse aggregate. Fine aggregate means the proportions of aggregates which are less than 4.75 mm or whereas fine aggregates proportions or portions which are greater than 4.75 mm or whereas coarse aggregate. This is the benchmark or demarcating point for differentiating the two types of aggregate, coarse aggregate, fine aggregate. The last one is water. This is the governing factor. This is the governing factor. Because why I am saying governing factor, water determines the strength of concrete and durability in everything. Okay, now in this material we have seen aggregates are inert material. Aggregates are inert materials. Aggregates are inert materials. Why I am saying it? Because aggregates don't involve any chemical reaction with the water or cement, which consumes 75% of the volume of concrete. 75% of the volume of concrete. Okay. So cement is the binding material. Aggregates we can split up into two parts. One is fine aggregates, another one is coarse aggregates. Fine aggregates in terms of size, the portions which are less than 4.75 mm or whereas fine aggregates, the portions which are 4.75 mm greater than or called as coarse aggregates, and the aggregates are inert materials. Aggregates makes up 75% of the volume of concretes. Last one is water, the governing factor. Okay, next. As I said earlier, the concrete is strong in compression and weak in compression by the tensile strength of concrete is equal to 1 by 8 to 1 by 10 of compressive strength of concrete. Next, we are going to see workability of concrete. It is a fresh concrete property. It is generally determined by the following case. First one is slump of base. Second one is compaction factor phase. Third one is flow phase. Fourth one is EB consistometer phase. Out of this, the most accurate one is compaction factor phase. First, what is workability? What is workability? Workability. The property of concrete by which we can easily mix the concrete and place the concrete and combat the concrete. If a concrete mix offers the easiness to mixing and placing and compacting, is called workability. So, workability, which means workability. Here the term plays a vital role in workability. Water cement ratio. Okay, what is water cement ratio? Ratio between weight of water and weight of cement. If the water cement ratio is higher, automatically the workability will also be higher, which means if we add more water, we can easily mix the concrete very easiness, and concrete will be more fluidable, flow over, we can easily mix and we can easily place it and compact it. But here, if the workability is more and the workability and strength of concrete are inversely proportional. Okay, got it? The strength of concrete and workability is inversely proportional to each other. If the workability is higher, the strength will be lower. If we need more strength, the workability has to be lower. But if we maintain the lower workability, the concrete will be more stiff and dry, and it gives more toughness to mix the concrete. So automatically there will be, when it gives resistance to the compact, so the honeycombs will be formed in the concrete. It will also affect the strength of concrete. How we can achieve the workability as well as strength in same? I need workability in high measure and also the strength by means of adding certain chemical admixtures, popularly known as super plasticizers. plasticizers and super plasticizers. We call it as water reducers. Water reducers. Okay. So these are the chemicals, water reducers. What we actually do in concrete is, when we add water to the cement particle starts to surround the water. Actually, we have to RD what we design, what the water cement ratio for the respective strength of concrete. We don't have to add even a single percent more than the water cement ratio. Okay. What actually happens in concrete is, when we add water to the cement particles starts to circulate the cement water molecules, which entraps the water. We have to release the water by means of adding super plasticizers. These super plasticizers, actually what do is, they will collapse this entrapped layer and will release the water from the entrapment. So automatically the water will actually add into the cement will release and will make the concrete more workable. And also straight. Next, we are going to see how do we determine the compressive strength of concrete. Okay, so here, as per the IS 543 S4 cement concrete, the compressive strength of concrete is determined by cube of size 150 mm and 150 mm and 150 mm. Here you can see the sample mold. Actually, first what we are going to do is, first we have to design the concrete for what strength you are designed to achieve. Next, we pour the concrete to the cube mold, that is 150 mm, 150 mm, 150 mm, and we pour into the cubic one for the base of 28 days, and after 28 days we take out the mold from the cubic one and dry it, and after that we have to test it on compression testing machine. Compression testing machine. So we have to check until it breaks, and the load is called compressive load. Compressive load, and the compressive strength will be calculated from the FCK. Usually called as compressive FCK. So the load divided by area, that is the compressive strength of concrete. For example, 15 or 20 we have